we're going to talk about antiderivatives. Antiderivatives undoes taking derivatives. And it's denoted like this. This means the antiderivative of x squared. Or let's just do an easier one. How about just x? Antiderivative of x, and it always ends with d followed by the letter that's involved here. That is, what do you take the derivative of to get x? That's what it's asking. You took the derivative and you got x. Now we want to work back. Well, turns out that x squared over 2 would work. Because if we take the derivative of that, we do get x. In fact, even if we added a constant, the derivative of this, since the derivative of a constant is 0, the derivative of this is that. We're undoing the derivative. What do you take the derivative of to get x? Where are you looking? In between the integral sign and the dx. You're looking here. What do you take the derivative of to get that? The answer is x squared over 2. In fact, you have x to a number, dx. This is asking, this here is asking the following question. The derivative of what gives you x to that number? Well, whenever you take derivatives of x to a number, the number always becomes 1 less. The derivative of x squared is 2x. The derivative of x to the 7 is 2x to the 1 less. 7x to the 6. The derivative of x to the 3 halves is 3x to the 1 half. 1 less than 3 halves is 1 half. So if I'm asking, so what do you take the derivative of to get this? The answer is add 1. Part of the answer is to add 1 to the power. What do you take the derivative of to get 2x? Whatever the power is, add 1. What do you take the derivative of to get x to the 7x to the 6? X to the 7. The power always goes up 1. Now, if you took the derivative of just this, you would get n plus 1, x, and the new power will become 1 less. You have n plus 1, and you take away the 1, you have n. The problem is this is not x to the n. Oh, just divide by n plus 1 and it will be. Divide by n plus 1 plus a constant. This here is a pretty important rule for a Calc 1 student to know. This rule right here. And we're even going to say one more comment about it. Like always, you can never ever divide by 0. Well, the bottom is 0 when n is negative 1. It's not 1. 1 plus 1 is not 0. But negative 1 plus 1 is. This rule is only true when n is not negative 1. This power cannot be negative 1. And if it is, later on, you'll learn their integral, or the antiderivative of x to the negative 1. Okay, so with that rule in hand, we could take derivatives, or antiderivatives. Another rule I want to tell you is, if you have a constant times some function, the antiderivative of that, just like derivatives, the constant can come out in front of the antiderivative. Can come out in front. That is, just take the antiderivative of f of x, multiply it by k. So if you were asked to find the antiderivative of the cube root of x dx, well, again, you only know how to take the integral of x to the n dx, where that power is not negative 1. It's the only thing you know how to take the derivative of. So we better write this in this form. Well, the cube root of x is x to the 1/3. Remember that nth root of x to the m is x to the this number over that number, x to the m over n. It's understood in the cube root of x that the power is 1. So I did 1 divided by 3. There it is. That fits right into this form. I add 1 to the power. Now, if you have a fraction and you want to add 1, which you want to usually do with integrals, you want to add 1 to the power. Think of the 1 as b over b. That is, whatever down here, think of this as that number over that number. And we're just going to do this once, and we'll get a nice formula. Where in addition, the denominators are the same, keep it the same. Add the tops, a plus b. Now, how do you go from the original fraction to this? Well, you add the top and the bottom. That gives you the new top, and the bottom stays the same. Okay, I'll add the top and the bottom. I'll get 4. 1 plus 3 is 4 over 3. 4/3 is 1/3 plus 1. 1/3 plus 1. Think of the 1 as this number over itself. That is 3 over 3. Keep the bottom, add the top. But how are we really getting 4? How can we get 4 more easily? You know, we can write all of this and say 1 plus 3 is 4. Or we can say 1 plus 3 is 4. And then we divide by this number. We divide by 4 over 3 plus the constant. There's the integral, or antiderivative. Another name for antiderivative is integral. Suppose you were asked to do the integral of dx over the square root of x. Well, you should realize that when there's no number right there, it's understood to be 2. And x is the same as x to the 1. So I know how to write that as an exponent. It's x to the this number over that number. I have. But this is not in standard form. I need to have the x to a power in the numerator. But I can do that. That's not a big deal. If something's in the bottom, I can bring it to the top, but I change the sign of the power. Okay, now it's in the form of the antiderivative of x to a number. And the number is not negative 1. So we're in business. I add the negative 1 into 2 when I get 1, and I keep the same denominator. And then I divide by this number, 1 over 2, plus the constant. And you don't have to note that you're dividing by 1. Now you can leave the answer like that, or you can say x to the half is the square root of x. Either one of those would work. But you need to say that you can add the constant. Let's use that rule that I gave you. Somebody asked you for the antiderivative of 7x to the 4th. Whether you write this step or not, the 7 kind of comes in front. There's 7. This is x, make the new power 1 more, divide by that power, plus the constant. You can do that right from here. There's the constant. There's x to a number. We want the antiderivative of that. Make the new power 1 more, divide by that same power, plus c. Same answer we got over here. Suppose you were asked to find the antiderivative of 1 over 2x cubed. Now remember, if you have a product that's being raised to a power, well, each of the factors gets raised to that same power, and you multiply. Just like you're multiplying a and the b, you multiply the a to the n by the b to the n. That is, the denominator is 2 cubed times x cubed. Just the x goes up to the top, and I change the sign of the power. The 8 can stay where it is, and it's a constant. It's a constant. I mean, after all, it's 1/8 the constant. We're not going to discriminate the constant because it's a fraction. Okay. The constant stays where it is. Add 1 to the power, and then divide by that same power, plus c. Okay. The bottom is -16, but I'll put the negative on the top. Okay. So I took care of the 8, the 2, and the negative sign. And the x squared, the x to the -2. Since it's a negative exponent and it's in the top, I'll put it in the bottom, make it +2. Okay, of course, plus c. Now you may say that there's no numerator. Well, that's not true. I can always multiply by 1. 1 times x to the -2, x to the -2, that is the 1 stays. Okay, realize that you're not going to bring the 2 up to the numerator. There's no reason. Okay, suppose you had the integral of x cubed plus 2x squared minus 3x plus 4 all over the square root of x dx. I mean, what's the antiderivative of what's inside the brackets? Well, let's clean it up a bit. Remember, x, the square root of x is x to a half. Now, remember, if you have, say, 7 over 4 plus 3 over 4 plus 11 over 4 minus 13 over 4, clearly the 7, the 3, the 11, and the 13 are all being divided by 4. Now, think about how you would calculate that fraction. Well, we're adding or subtracting, and all the denominators are the same. They're all 4, so they stay 4. The numerator will be 7, will be the result of 7 plus 3 plus 11 minus 13. Let's just make the 11 12. Let's just make it 12. Okay. You can say 4 goes in the 12 3 times, so the answer is 7 plus 3 plus 3 minus 3. That's not true. Why? Because this equals what's on the left side. And the left side says divide the 7 by 4, divide the 3 by 4. Also here, divide the 12 by 4. And don't forget to divide the 13 by 4. Each of these terms gets divided by 4. I know it does. It says so on the other side. And they're equal. Each of the terms get divided by 4. In our case, each of the terms in the numerator will get divided by the square root of x. Each of the terms in the numerator will get divided by x to the half. Remember, when the bases are the same and you're dividing, you subtract the exponent. X cubed divided by x to the half, well, 3 minus a half. Remember, 3 is the same as 6 halves. 6 halves minus 1 half is 5 halves, plus 2 x to the power. 2 to the power 2 is 4 halves. Take away 1 half, get 3 halves. The power here is understood to be 1, which is 2 over 2. Take away a half, get 1 over half. So it's minus 3x to the 1 half. Plus 4 over x to the half. But I don't want x's in the bottom. So I'll bring the x to the half to the numerator and x to the minus a half. And now I can integrate. Oh yeah, maybe I slipped this in an earlier problem. But if you have a sum, here's another rule. If you have a sum, you can integrate the first, say, function, plus or minus, depending upon what the sign is, plus the integral of the second function. Now, think of this as f of x plus g of x plus 8 minus h of x plus j of x. This rule on the bottom doesn't just work with two functions. Okay? So, let's find the antiderivative of x to the fifth. You add 1 to the power. Let me erase the bottom. I need a little bit more room. You add 1 to the power. Since the power is a fraction, you just add divided into 2. That gives you the new power, the new numerator, and divided by the same denominator, 2. And since we are integrating, we should have that symbol there. And then we divide by that same power, 7 over 2, plus 2. I add the 3 and the 2, I get 5. And I divide by 2. And then I divide the whole thing by 5 over 2. Minus 3. The new power, the numerator will be 1 plus 2 or 3 over 2. And then I divide by 3 over 2. Coincidentally, the 3's cancel. Plus 4x. I add negative 1 and 2. I get 1 over 2. And then I divide by 1 over 2. Plus c. Okay, let's just clean this up. We get 2x is 7 over 2 over 7. 2 times 2 is 4. 4x, make this a little bit smaller. 4x to the 5 halves, there's a 5 there. 4x to the 5 halves over 5. Minus the 3's cancel. 2x to the 3 halves. Plus 2 times 4 is 8. X to the half. And you don't have to denote that you're dividing by 1. Plus your constant. There is your answer. There is your answer. The antiderivative of one function times another function, more likely than not, is not equal to the integral of the first somebody asks you what is the antiderivative of, what's in here, say x plus 3 times 2x minus 5, don't use the rule above because it's not true. Multiply out. See what you're taking the integral of. X times 2x is 2x squared minus 5x. Again, you're adding back 6x. That leaves 1x. And positive 3 times negative 5, negative 15. Okay. The antiderivative of 2x squared, well, the constant stays. Make the power of x one more, and divide by that same power. Plus, understand that there's a 1 there. Make the new power one more, divide by that new power. Minus. Now, there are two ways of handling the constant. You can ask yourself, the derivative of what gives you 15? And I hope you would just say, oh, 15x. The derivative of 15x gives you 15. Or you can say that 15 is the same as 15 times 1. X to the 0 is 1. Don't do it this way. The derivative, the antiderivative of a constant is a constant times x. And here's why. The constant can come out in front. Now we have x to a number dx. As long as that power is not negative 1, and it isn't, we can use our rule. Add 1 to the power, and then divide by that power. 15 over 1 is 15. You get 15x plus the constant. Plus the constant. Now, you may be saying, you know what? Something he said earlier, he's not living up to. Now, I did say that this is the same as the integral of 2x squared dx plus the integral of x dx minus the integral of 15 dx. And the integral of 2x squared is 2x cubed over 3 plus c. I'll call it c1. Plus, let's say plus, the antiderivative of x is x squared over 2 plus another constant. No reason to assume it's the same constant, so call it c2. Minus the integral of 15, which is 15x plus c3. c1 plus c2 plus c3, I'm just calling it one constant, c. And notice that this is exactly what I got. To the right here, I got 2x cubed, there it is, over 3, plus x squared over 2, there it is, minus 15x, there it is, c1 plus c2 plus c3, I'm calling that plus c. You want to say minus c, say minus c. Doesn't matter. If c is negative, like if we're adding a negative 7, well, that would be the same as taking away 7. You can get away with always saying plus c. And the integral of a product, and the antiderivative of a product is not the product of the antiderivatives. Okay, the letters don't matter. Somebody asks you what the integral of x squared plus 3x plus 4 was. Since this is in terms of x, it should say dx. Or somebody asks you what the integral or the antiderivative of t squared plus 3t plus 4 is. Since this is in terms of t, it will say dt. On the left, it's going to be x to the 1 more power over that number. There's an understood 1 there, plus the constant x to the 1 more over that same number, plus the antiderivative of a constant. That is the derivative of what gives you a constant. The answer is that constant times x, plus c. Plus c. On the right side, you're going to get the same answer, except it's going to be, the variable is going to be t. Should look exactly the same, except it'll say t. Instead of x, put t. Put t. And that's exactly what we should have here. The alphabet soup. Don't get caught up with the letters. This is one of the more straightforward chapters or sections. You have to know is your algebra to simplify the function, so there's nothing more than x to a number. So, suppose instead I say find y if dy dx is 3x plus 5. So basically, I'm giving you the derivative, here it is, and I'm asking you for the original function. I'm asking you to undo the derivative. That is, I'm asking you for the antiderivative. The answer is y is equal to the antiderivative of 3x plus 5 in terms of x dx. So I solved that. There's an understood 1 here. The constant 3 stays. And take the antiderivative of this, antiderivative of that, then I'm going to add them. And make the power 1 more, divided by that same power. Plus, the antiderivative of constant is that constant times x, plus an arbitrary constant. The best you can say is y is equal to 3x squared over 2 plus 5x plus c. That's the best you can do. If it turned out that that graph looks like this, that is c is 0, because I'm adding 0. Well, if c was 1, I would get this graph. If c was 2, I would get that graph. -1, -2, etc. All of those are graphs of y. We know y wasn't a constant. Given what we were given, we don't know what y is exactly. Unless they give us some kind of condition. Suppose they tell you a couple of things. They tell you dy dx is equal to x to the 4th plus 2x cubed, and they tell you that y up 2 is equal to 7. Okay. Well, from here, we can get y, or f of x. Remember, another name for y is f of x. We can get f of x, what's in a constant, based on what's in the box here. And then, with this information, we can find out what that constant is. For example, just from here, we know that y is the antiderivative of x to the 4th plus 2x cubed dx. And that equals x to the fifth over 5 plus 2x to the fourth over 4 plus the constant. Now, to make my life a little bit easier, I'm going to rewrite the problem, and I'm going to call the constant in front of the x to the 4, 5. So the 5's will cancel. And one other change. I could have done this before, but I didn't. So in fact, why don't we just redo this completely? And the constant in front of x cubed will be a multiple of 4, say 4. So the antiderivative of this will be just the antiderivative of 5x to the 4 plus 4x cubed, all of it times dx. And that gives us the integral of antiderivative of this plus antiderivative of that. The antiderivative of 5x to the 4th, well, 5 is a constant, it stays. The antiderivative of x to the 4, add 1 to the power, divide by that same power. Coincidentally, the 5's cancel. Plus, antiderivative of 4x cubed, well, 4 is a constant, it stays there. The antiderivative of x cubed is x to the 4 over 4. Plus an arbitrary constant. And the 4's cancel. So this is what we have for y, or f of x. X to the fifth plus x to the 4th plus c. Remember, this is the same as f of x. So f of 2, on one hand, is 2 to the fifth plus 2 to the 4th plus c. 2 to the fifth is 32 plus 2 to the 4th is 16 plus c. That is, it's 48 plus c on one hand. On the other hand, we're told that f of 2 is 7. So bringing the 48 to the other side, we will learn that c is equal to negative 41. So right here, I'll write down what f of x is. Oh. If dy dx equals that, and f of 2 equals that, find f of x. Maybe I said that in words, but there it is. Instructions are to find f of x. That f of x is equal to, I'll get it from right here, and I'll use the fact that c is, positive c is negative 41. So f of x is equal to x to the fifth plus x to the 4th, and plus c is negative 41. There it is. C needs to be negative 41, so f of 2 is 7. Now sometimes they give you what they call their initial condition. And they like, that kind of means that x is 0. Or t is 0. Initial, t stands for time, and the initial time is when you first start, and that's when t is 0. So you're given that dy dt is equal to 6t squared minus 4t plus 2, and f of 0, the initial condition is 4. Find f of t. Well, f of t or y is equal to, well, if you're given the derivative, of f of t, that is, this here is f prime of t, the derivative of what? Well, that's f prime of t. When you're given the derivative and you find the antiderivative of that, well, you get back f of t. And f antiderivative of this minus that plus 2, the antiderivative of 2. That will be f of t. 6, antiderivative of this. The constant case. Make the new power 1 more, divide by that number. Minus the antiderivative of 4t. 4 is a constant. T is understood to be t to the 1. Make the new power 1 more, divide by that number. Plus the antiderivative of 2 will be 2t plus a constant. This here is the best you can do given the derivative. But 3 goes into 6 2 times, 2 goes into 4 2 times. That's the best you can have if they didn't tell you the initial condition. But they're telling you, on one hand, f for 0 is 4. Well, using this equation right here, f for 0 is 2 times 0 cubed minus 2 times 0 squared plus 2 times 0 plus c. Well, this is 0, this is 0, this is 0. You add or subtract zeros, you get 0 plus c is plus c. And plus c is 4. So, with these two pieces of information, that is, we have f for t from this equation here, and we just learned that c is 4. So I'll update this equation right here by just saying, oh, t is 4. In fact, there's the answer. F for t is equal to 2t cubed minus 2t squared plus 2t plus good old 4. That's what f for t is. Given our condition, you can find f for t. Okay. Now, I'm going to give you some information and want to find f of x. I want to find f of x. I'll tell you, say, find f of x, f double prime of x is equal to 3. F prime of 2 is equal to 1. And f for 0 is 7. Okay, f for 0 equals 7. So given that, we want to find f of x. Well, they give us f double prime. We know that f double prime of x is equal to the constant. So if we find the antiderivative of f double prime of x, well, if we undo the derivative on the left side, we'll get the first derivative. We undo the derivative here, we get 3x plus the constant. I'll call that C1. Okay, well that gives us f prime of x up to a constant. If I take the antiderivative of f prime of x, that is, if I undo the derivative of f prime of x, I'm going to get back f of x. I'm going to undo the derivative on the right side. When you undo the derivative of 3x, you get 3x squared over 2. Plus, now C1 is a constant. The antiderivative of a constant is that constant times x. Plus a constant. Call that C2. So we have f of x up to two constants. There it is. But they gave us some initial conditions. They told us that f prime of 2 is 1. Well, on one hand, f prime of 2 is equal to 3 times 2 plus c1, namely 6 plus c1, which is 1. If I bring the 6 to the other side as minus 6, 1 minus 6 is negative 5. So c1 is negative 5. Okay? I'll keep that in mind. Wherever I see plus c1, I can put negative 5. So, actually, let's do that now. The f of x is 3x squared over 2 minus 5. I store plus c1 up at minus 5x plus c2. Now I'm going to use the fact that when x is 0, I get 7. Well, let's ask for 0. You should know that you're just going to get the constant. Because 0 squared is 0. 3 times 0 is 0. Divided by 2 is still 0. 5 times 0 is 0. 0 minus 0 is 0. 0 plus c2 is c2. So on one hand, using this formula right here, f is 0 is c2. On the other hand, we're told it's 7. So I'm going to copy down the line above, except instead of c2, I'm going to put 7. The f of x is 3x squared over 2 minus 5x. And instead of c2, I'm going to put good old 7. There it is. We were given two conditions. There were two unknowns. One here and one there. C1, C2. We had to find out what they were. Two things we had to find out. They had to give us two pieces of information. Okay, let's try one more like this. Suppose I tell you that f double prime of x is equal to x, and I tell you f prime of 1 is equal to 3, and I tell you f for 0 is equal to 4, and f double prime of x, I'm going to change it to 4x. I'm going to change it to 6x. I'm going to change it to 6x. Okay. So we basically work with this. If I take the antiderivative of the left side, gives me f prime of x, which is good. I'm getting closer to f of x. Instruction is, given everything above this line, find f of x. Okay, I took the antiderivative of f double prime of x, get f prime of x. If the antiderivative of this, I'm going to get 3x squared. I made the new power 1 more, and I divided by that same number. But 2 does go into 6 3 times. But every time you do an antiderivative, every time, you get a constant. We'll call that constant C1. And still, 2 goes into 6 3 times. So I get 3x squared plus C1. Now, I can find the constant, because I know that f prime of 1 is 3. F prime of 1, on one hand, using this rule, it's 3 times 1 squared plus C1. 1 squared is 1. 3 times 1 plus C1. 3 times 1 is 3 plus C1. On the other hand, I'm told it's 3. So that tells me what C1 is. It's 0. C1 must be 0. Only 3 plus 0 gives us 3. Okay, so let me update this formula right here. F prime of x is equal to 3x squared plus 0, which is just 3x squared. Now, if I take the antiderivative of this, the antiderivative of f prime of x, if you undo f prime of x, you get f of x. You take the antiderivative of this, the constant stays, make the new power one more, divide by that number. Coincidentally, the 3's cancel. Plus a constant, call it C2. So I get x cubed plus C2. And on one hand, f for 0 is 0 cubed plus C2. 0 cubed is 0 plus C2. Well, that's C2. On one hand, using this rule, I found out what f for 0 is. If they told me it was 4, oh, C2 is 4. I update this formula with the fact that C2 is 4. So f of x, copying down this line, f of x is equal to x cubed plus C2. Because C2 is 4. That's what f of x is. We can verify it. The first derivative will be 3x squared. And when you plug 1 in for x, you do get back 3. That is, f prime of 1 is 3. Okay? If you take the antiderivative, oh, and also, f for 0 is 4 from this rule right here. F for 0 is 4. Now, if you take the derivative of this, the left side gives you f double prime, and the right side gives you 6x. Exactly what we were supposed to get. Has to fit together like a glove. Okay, that finishes this section.